Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into deep space, into a question that has lingered quietly in the background of human curiosity for centuries. Is the universe more terrifying the more we understand it? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a gentle reminder that while we may be scattered across this planet, we're all sharing the same sky, just at different moments. Now, feel free to dim the lights. Maybe turn on a fan for a soft background hum, and let's gently begin our journey into deep space together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Tonight, we won't rush. We won't overwhelm. We'll simply explore, slowly, softly, like watching distant stars flicker into view. And perhaps, along the way, you may begin to notice something subtle, that the more we learn about the universe, the less it feels like a distant, silent painting, and the more it begins to feel like something vast, ancient, and quietly indifferent. But for now, let's begin somewhere familiar. If you've ever stepped outside on a quiet night, maybe long after the world has gone still, you might have looked up at the sky and felt something gentle settle over you. The stars, scattered softly across the darkness, often feel calm, predictable, almost comforting. They don't rush, they don't flicker violently, they simply exist, quietly. For thousands of years, humans have looked at those same points of light and imagined stories, constellations, myths, guides for travellers, symbols of something greater, yet somehow safe. And even now, with all our modern knowledge, that feeling hasn't completely disappeared. The night sky still feels peaceful, distant, untouchable. But that sense of calm might be an illusion, because what you're looking at is not a quiet ceiling of lights. It is a vast three-dimensional ocean of objects and forces so extreme, so far removed from human experience, that the mind naturally softens them just to make them easier to hold. And here's where something interesting begins to happen. Most fears we experience come from what we don't understand, the unknown, the unseen, the unexplained. It's natural to feel uneasy about things we can't fully grasp. But space is a little different, because in many ways, what we do understand is just as unsettling. The more we learn about the universe, the more we begin to realize that it isn't simply mysterious. It is structured in ways that are deeply unfamiliar to us, not chaotic in the way we might expect, but governed by rules that don't bend for comfort, intention, or life. Rules that quietly continue, whether anything survives within them or not. Take a moment, for example, to consider just how far away those stars are. The closest star beyond our sun is so distant that even light, the fastest thing we know, takes years to arrive from it. Light, which can circle the Earth several times in a single second, still needs years to cross that distance, and most of the stars you see, they are much farther still. So when you look up, you're not seeing things as they are now, but as they were long ago. Some of those stars may have already changed, faded, or even disappeared, and their light is only just reaching you now, like a quiet echo travelling through time. It's a strange thought, that what feels immediate is actually delayed, that what looks stable may already be gone, and yet, from this distance, everything appears calm. This is one of the subtle ways the universe hides its nature. Distance softens everything. It turns violent events into faint glimmers. It compresses enormous scales into tiny points of light. A star that could engulf entire worlds becomes something you can cover with your fingertip. But understanding begins to peel that illusion away, because when you move just a little closer in your imagination, things begin to change. You begin to realize that those gentle lights are not small. They're not quiet. They're vast spheres of energy, constantly transforming matter into light and heat, radiating outward in all directions, and even that description is still softened. In reality, many of these stars are unstable. Some are short-lived, some are massive beyond easy comprehension, and some will end their lives in ways that release more energy in a brief moment than entire galaxies do over long stretches of time. But again, from here, they simply twinkle. There's something almost poetic about that the most extreme objects in the universe can appear so gentle when viewed from far enough away. And perhaps that's where the deeper question begins to take shape. Is the universe truly peaceful, or does it only seem that way because we are so small and so distant from everything else? Because as we begin to look closer, not physically, but through understanding, we start to see a different picture emerge. A universe where most environments are not just unfamiliar, but completely incompatible with life as we know it. A universe where balance is rare, where stability is temporary, where conditions that allow something like you to exist, think, and feel are the exception rather than the rule. And yet here you are, sitting somewhere on a small planet under a quiet sky, listening to a story about a universe that, in most places, would not allow you to survive for even a moment. It's a strange contrast, and maybe a meaningful one, because fear, in this context, doesn't have to be overwhelming. It doesn't have to be sharp or urgent. It can be something softer, a kind of quiet awareness, an understanding that the universe is not built for us. And yet, somehow, we have found a place within it where life can exist, where warmth is just right, where light arrives at the right intensity, where the ground beneath you holds steady, a place that feels almost unlikely. And as we continue this journey, we'll slowly move outward from this small, comfortable island into regions where those conditions begin to fade, not abruptly, not dramatically, but gradually, like stepping away from a warm light into a cooler, darker space. And with each step, we'll begin to see the universe not just as something beautiful, but as something vast, precise, and quietly indifferent. A place where understanding doesn't remove fear, but reshapes it into something calmer, deeper, and perhaps a little more honest. And for now, you can simply rest with that thought. If you stay with that image of the night sky for just a moment longer, something subtle begins to shift. Those distant stars may feel far away, almost abstract, but closer to home, much closer, lies a region we often imagine as familiar, predictable, perhaps even safe, our own solar system. It's where everything we've ever known exists. The sun rises and sets. The planets move in steady, repeating paths. There is a rhythm to it all that feels reassuring. And because of that rhythm, it's easy to assume that this part of the universe, our part, is somehow calmer than the rest. But that assumption, like many others, begins to soften when you look just a little closer. Let's begin with Earth. Here, everything feels balanced in a way we rarely notice. The air is breathable. The temperature, most of the time, is neither too hot nor too cold. Water flows, clouds form, and life, quietly and persistently, continues. It can feel so natural that it almost seems inevitable. But if you shift your gaze slightly outward to our nearest planetary neighbours, That sense of inevitability begins to dissolve. Take Venus, for example. From a distance, Venus appears bright, smooth, almost serene. For a long time, it was even imagined as a kind of tropical world hidden beneath thick clouds. But those clouds are not gentle. They trap heat so effectively that the surface below becomes hotter than a kitchen oven left on at full power, not for minutes, but continuously. The air itself is dense and heavy, pressing down with a weight that would feel overwhelming. And the ground beneath that thick atmosphere is not calm or inviting. It is dry, cracked, and hostile to anything we would recognize as life. Now drift a little farther out, beyond Earth, to Mars. Mars feels different. Not hot but cold, not dense but thin. Its atmosphere is so light that it can barely hold warmth. The surface is quiet, almost still, but in a way that feels empty rather than peaceful. It's a world where something once may have flowed, but no longer does. And then, further still, we arrive at something entirely different. Jupiter. Unlike Earth, unlike Mars, unlike anything we experience directly, Jupiter does not have a solid surface you could stand on. There is no ground waiting beneath your feet. No clear boundary where sky becomes land. Instead, what you would encounter is layer upon layer of thick, swirling clouds. Bands of colour stretching across the planet, moving slowly from a distance, but hiding immense motion within them. If you were to descend into that atmosphere, even just in imagination, you would find yourself moving through winds that grow stronger and more chaotic the deeper you go. The light would begin to fade, not suddenly but gradually, as the upper layers of clouds thicken above you, and beneath those clouds, the environment becomes stranger still. Pressure builds, temperature rises, the very nature of matter begins to change. At some point far below, the gas is compressed so intensely that it behaves less like a gas and more like a dense flowing substance, almost like a vast ocean made of something unfamiliar. There is no place to land, no surface to reach, just a continuous descent into something deeper, heavier, and more extreme. And if somehow Earth itself were to wander too close to Jupiter, the result would not be a dramatic collision in the way we might imagine from films or stories. It would be quieter, more absolute. Earth would be pulled in, stretched, and gradually absorbed into that immense atmosphere, like a drop of ink dispersing into water, losing its shape, its identity, until nothing distinct remains, no explosion, no clear boundary, just disappearance. And this is still within our own solar system. The place we often think of as our immediate cosmic neighbourhood. What begins to emerge from these comparisons is something subtle but important. The conditions that make Earth feel stable, breathable, livable, are not the norm. They are the exception. A narrow balance of distance, temperature, atmosphere, and timing, all aligning in a way that allows life to exist, to evolve, and to become aware of itself. Move slightly closer to the sun, and heat becomes overwhelming. Move slightly farther away, and cold takes over. Change the composition of the atmosphere, and breathing becomes impossible. Remove the magnetic field, and invisible particles from space begin to strip everything away. It doesn't take much. Just a small shift in any direction, and the environment changes completely. And perhaps that is where a deeper realization begins to settle in, that Earth is not simply home, because it is where we are. It is home because against a backdrop of countless other possibilities, it happens to be one of the very few places where the conditions align just right. Not perfect, not permanent, but sufficient. And even that sufficiency exists within a larger system that is anything but gentle. The sun, for instance, provides the light and warmth that sustains life here. But it is not a calm object. It is a massive, active sphere of energy, constantly releasing streams of particles and radiation into space. From the right distance, this energy supports life. From a slightly different distance, it would overwhelm it. And so, what we begin to see is not a peaceful system, but a balanced one. A system where forces that could easily become destructive are held, for now, in a kind of delicate equilibrium, and that equilibrium is not guaranteed. It is simply what happens to be true at this moment. As you sit here listening, the Earth continues to move around its axis, around the sun, and together with the sun, around the center of the galaxy. Everything is in motion, not rushed, not chaotic in the way we experience chaos, but constant, unstoppable. And within that motion, this small window of stability persists, for now. There's something quietly humbling about that the place we experience as steady and reliable is, in a much larger sense, part of a system that is dynamic, powerful, and in many ways indifferent, not hostile in intention, but unconcerned. And yet, within that indifference, life has found a way to exist, to observe, to reflect, to wonder, to sit beneath a sky that feels calm, while knowing just beneath that calmness there is something far more complex unfolding. And as we continue to move outward, beyond our solar system, the complexity will only deepen, the environments will grow more extreme, the scales will stretch further, and the sense of familiarity will begin to fade. But we won't rush there. We'll move slowly, step by step, allowing each layer of understanding to settle gently into place. For now, it's enough to recognize this, even here, in what feels like the most familiar part of the universe. Safety is not the default. It is a rare and temporary arrangement, and perhaps that makes it all the more meaningful. As you gently drift a little farther outward, beyond the familiar paths of the planets we know, the sense of recognition begins to fade. The sun, once a central anchor, slowly becomes just another star among many. The orbits that once felt structured and predictable give way to something far more varied, far more imaginative, and in many ways far less comforting. For a long time, humanity didn't know whether planets existed beyond our solar system at all. It was only relatively recently, within the last few decades, that we confirmed their presence. And since then, what we've discovered has been quietly astonishing. There are not just a few planets out there. There are billions upon billions of them. So many, in fact, that if you were to try to count them one by one, even at a pace of one every second, you would never finish within a human lifetime. And among this vast collection of worlds, Earth is not the standard. It is the exception. Many of these planets are unlike anything we've ever experienced. Not just different in small ways, but fundamentally different in how they behave, how they form, and what it would feel like to exist there, even for a moment. Some are so close to their stars that their surfaces are constantly heated to temperatures that would melt rock, not gradually, but continuously, as if the entire world were caught in an endless glowing twilight of heat. Others are locked in such a way that one side always faces their star, while the other remains in permanent darkness. A world divided into eternal day and eternal night, with no sunrise, no sunset, only a fixed sky that never changes. And then there are worlds that seem almost familiar at first glance, but reveal something far more unsettling when you look closer. One such world is known as HD 189733b. From a distance, it appears almost beautiful, a deep, rich blue, with soft swirling patterns that resemble oceans seen from space. If you didn't know better, you might imagine it as a peaceful water-covered world, calm, serene, perhaps even inviting. But that appearance is misleading, because what creates that deep blue colour is not water. It is light scattering through an atmosphere filled with tiny particles that, under the right conditions, form something closer to glass than to liquid. On this planet, the winds move at incredible speeds, faster than anything we experience on Earth. So fast, in fact, that if you could stand there, which you couldn't, the air itself would feel less like a gentle breeze and more like a constant invisible force pressing against you, and carried within those winds are fine fragments, not soft, not harmless, but sharp, solid, and moving sideways through the atmosphere at tremendous speed. Imagine standing in a place where the sky itself moves with force, where the air carries countless tiny particles across the landscape, not falling gently, but sweeping across in continuous motion. Not a storm that passes, but a condition that simply is. The temperatures there are also far beyond anything we would find comfortable. Heat is not something that comes and goes with time of day. It is constant, ever-present, surrounding everything. And yet, from far away, it looks like a calm blue world. This is something we begin to notice more and more as we explore these distant planets. That appearance can be deceiving. That beauty, in the context of the universe, does not necessarily mean safety. In fact, some of the most visually striking worlds we've discovered are also among the least hospitable. And this raises an interesting thought, that the universe does not organize itself around what is comfortable or livable. It does not prioritize stability or habitability. Instead, it simply follows the rules of physics, allowing matter and energy to arrange themselves in whatever ways those rules permit. And sometimes, those arrangements lead to conditions that feel almost unimaginable. Worlds where temperatures swing wildly between extremes. Worlds with atmospheres so thick or so thin that breathing would be impossible. Worlds where gravity pulls differently, where time might feel subtly altered, where nothing behaves quite the way we expect. And yet, all of these worlds are real. They are not theoretical, not imagined. They exist, quietly orbiting their stars, far beyond the reach of our everyday experience. There's something both humbling and unsettling about that what we consider normal, a stable surface, breathable air, gentle weather, is not the baseline. It's a narrow window, a specific combination of factors that just happens to allow life, as we know it, to persist. And outside that window, the possibilities expand dramatically. But those possibilities are not necessarily kind. They are simply allowed. And perhaps this is where a deeper layer of understanding begins to form. That the universe is not filled with places waiting to be discovered, in the sense of being welcoming or compatible. It is filled with environments that exist entirely on their own terms. Places where the idea of survival doesn't really apply, because the conditions were never meant to support it in the first place. And yet we continue to search, to observe, to learn, to imagine what it might be like to stand or float within these distant worlds. Not because we expect to live there, but because understanding them helps us understand something else, something closer to home. It reminds us that Earth, with its balanced temperatures, flowing water and breathable air, is not just familiar, it is rare, and perhaps even fragile. Because when you look at the countless worlds beyond our solar system, you begin to see that the universe does not naturally settle into places like Earth. It drifts toward extremes, toward heat, toward cold, toward pressure, toward motion, and every once in a while, in a small quiet corner, those extremes balance out just enough to create something stable, something temporary, something like home. As we continue outward from here, the scale will grow even larger. Planets will give way to stars, and stars to something even more immense. And with that shift in scale, the sense of familiarity will fade even further. But for now, you can rest with this thought, that beyond the small circle of worlds we know, there are countless others, each shaped by the same laws of nature, yet unfolding in ways that feel almost unreal. Not because they break the rules, but because they follow them so completely. As your thoughts drift a little farther outward, beyond distant planets and unfamiliar worlds, something begins to shift again. The scale changes. What once felt large, planets, storms, entire atmospheres, now begins to feel smaller, quieter, as something much more immense slowly comes into focus. Stars. For most of human history, stars were points of light, tiny, distant, decorative almost. They marked seasons, guided travellers, and filled the night with a sense of quiet wonder. Even now, when you look up at the sky, they still feel that way. Small, but that smallness is only an illusion created by distance, because each of those faint lights is not a point at all, but a vast sphere of energy, a place where matter is constantly being transformed, where light and heat are released in enormous quantities, flowing outward into space. And among those countless stars, there is one that feels deeply familiar, the sun. It's easy to think of the sun as something extraordinary. It dominates our sky, it warms the earth, it makes life possible. Without it, everything here would grow cold and still. It feels powerful, and in many ways it is. But in the broader context of the universe, the sun is not special. It is average. That might sound surprising at first. After all, the sun feels enormous compared to Earth. If you imagine placing Earth beside it, our planet would appear as a small sphere next to something vastly larger, almost insignificant in comparison. You could fit over 1 million Earths inside the sun and still have space left over. And yet, even with that scale, the sun sits quietly in the middle range of what stars can be. There are stars smaller than the sun, yes, dimmer, cooler, longer lived. But there are also stars that are far larger, far brighter, and far more extreme. And to begin to understand that difference, it helps to build a gentle ladder in your mind. First, imagine Earth, a place with oceans, continents, and a thin layer of air wrapped around it. Now expand that image outward to something like Jupiter, a world so large that if Earth were a small bead, Jupiter might feel more like a large ball beside it, vast, layered, and heavy with gas instead of solid ground. Now take that comparison and expand it again, from Jupiter to the Sun. The Sun is so much larger that Jupiter, despite its size, would seem small in comparison. The Sun contains nearly all the mass in our solar system. Everything else, planets, moons, asteroids, are just a small fraction of what it holds. And yet, this is still only the beginning, because if you continue climbing that ladder, you eventually reach stars that make even the Sun feel modest. Stars that stretch outward so far that if placed at the centre of our solar system, they would extend beyond the paths of multiple planets. One such example is WOHG 64. This is not a star you could easily imagine standing beside. It is not something you could observe from nearby and still feel grounded. It is a star so large that if it replaced the Sun, it would expand outward, filling the space where several planets now orbit. Worlds like Earth would not just be warmed by it, they would be inside it, not touching its surface, but immersed within its outer layers of glowing gas. a place where the concept of distance from the star no longer applies in the way we understand it. Everything would be enveloped, and within that vast structure, temperatures rise, energy flows, and matter moves in ways that are difficult to picture in everyday terms. It is not solid, not fixed, more like a slow, luminous ocean stretching across unimaginable distances. And this raises an interesting realization that even something as powerful and essential as our sun is not the upper limit. It is simply one example among many, and perhaps more importantly, it is a relatively stable one, because as stars grow larger, they often become less stable. They burn through their energy more quickly. They shine brighter, but for shorter periods of time. Their internal balance, the quiet tension between gravity pulling inward and energy pushing outward, becomes more difficult to maintain, and over time, that balance can shift, not gradually, but suddenly. But for now, we don't need to rush to that moment. Instead, it's enough to sit with this expanding sense of scale, to notice how something that once felt enormous now feels smaller when placed in a wider context, and how that pattern continues. Earth felt large, until we compared it to Jupiter. Jupiter felt vast, until we compared it to the Sun. The Sun feels immense, until we compare it to other stars. And beyond those stars, there are structures even larger still. Each step outward doesn't just increase size, it changes perspective. It reminds us that what feels central may not be. What feels extreme may be ordinary, and what feels permanent may be part of a much larger cycle. There's something quietly humbling about that the source of all life on Earth, the Sun itself, is just one of countless stars scattered across the galaxy, a single light among billions. And each of those lights has its own story, its own structure, its own lifespan. Some will remain stable for billions of years, others will change more quickly, some may host planets, others may not. But none of them are arranged with any intention. They simply exist, following the same underlying rules. And within those rules, a vast diversity of outcomes unfolds. As we continue this journey, we'll begin to see what happens when those outcomes reach their limits, when stars grow too large or too unstable to maintain their balance, when the quiet glow of a star gives way to something far more dramatic. But even then, we will move slowly. There's no need to rush into intensity, because even the most powerful events in the universe begin quietly, with small shifts, small imbalances that gradually build over time. And for now, it's enough to recognize this. The Sun, as bright and life-giving as it is not unique. It is one light among many, and beyond it, the universe continues to expand in scale, in complexity, and in quiet, indifferent motion. As you remain with that image of the Sun, gently glowing, steady, familiar, it can be comforting to imagine it as something immense and dependable, and in our everyday experience it is. But as your perspective slowly widens, as your mind steps just a little farther back, the Sun begins to shift in meaning, not in what it is, but in how it compares. Because among the countless stars scattered across the galaxy, there are some that grow far beyond what we might intuitively expect. Not just larger, but so expansive that even the idea of a star begins to feel insufficient to describe them. They are not points of light. They are regions of space filled with slow, luminous movement, stretching outward in all directions. One such star is WOHG 64. If you imagine placing this star at the center of our solar system, something unusual begins to happen. The orbits of the inner planets, Mercury, Venus, Earth, would no longer circle around it from a distance. They would be inside it, not touching a surface, because there is no clear surface in the way we think of one, but moving through its outer layers, as if drifting through a vast glowing atmosphere. Even Mars, and beyond, would be enveloped. The idea of a solar system with empty space between planets and a central star begins to dissolve. Instead, everything becomes immersed within the star itself, surrounded by heat, motion, and light. And yet, even this description is still a simplification, because these stars are not solid structures. They are not stable objects in the way a planet is. They are more like enormous, slow-moving oceans of gas and energy. Their outer layers expand and contract. Their brightness changes over time. Their internal structure shifts in ways that are difficult to visualize without turning to complex physics. But we don't need to describe them in technical terms to feel their scale. It's enough to imagine standing, if such a thing were possible, within a region where there is no ground beneath you, no clear sky above you, only a continuous gradient of glowing material stretching outward in every direction, a place where direction itself becomes less meaningful, where up and down lose their usual definitions, and within that immense structure, processes are unfolding that determine the star's future. Because stars like this do not remain in this state forever. They are, in a sense, living on borrowed time. The larger a star becomes, the more quickly it uses the energy stored within it. It shines brighter, but at a cost. Its internal balance becomes more delicate. At the core of every star there is a quiet tension. Gravity is always pulling inward, trying to compress the star into something smaller, denser. At the same time, energy produced inside the star pushes outward, resisting that collapse. For a while, these two forces remain in balance. That balance is what allows a star to shine steadily, to exist in a relatively stable state. But in very large stars, this balance is harder to maintain. They burn through their energy more quickly. Their internal processes become more complex, and eventually, that balance begins to falter, not all at once. At first it may be subtle, a gradual change in structure, a shift in how energy flows from the core to the outer layers, small variations that over time grow more pronounced. And then, something changes. The outward push weakens, gravity begins to take over, and the star, which once expanded outward so dramatically, begins to collapse inward. It's a quiet reversal, an inward motion where there was once expansion. And as this collapse continues, it doesn't simply lead to a smaller star, it leads to something far more dramatic. But again, we don't need to rush there just yet. Instead, it's worth pausing with this idea that even the largest, most expansive star are not permanent. They are temporary arrangements of matter and energy. They grow, they change, they evolve, and eventually they transform into something else. There's something quietly humbling about that even structures so vast they can envelop entire planetary systems are still part of a larger cycle. They are not final, they are not fixed, they are moments stretched across time. And in that sense, they are not so different from smaller stars like our Sun, just larger, brighter, and shorter lived. As you reflect on this, the pattern becomes clearer. Scale does not bring stability, it brings intensity. The larger something becomes, the more energy it contains, and the more delicate its balance can be, and the more dramatic its transformation when that balance is lost. So while these enormous stars may appear magnificent, even serene from a distance, they carry within them the seeds of their own change, not as something sudden or violent in intention, but as a natural consequence of how they exist. And as we continue to move forward, we'll begin to see what happens when that transformation unfolds, when a star no longer holds itself together. When the balance between inward pull and outward pressure finally gives way, and when something entirely new emerges from that moment. But for now, you can simply rest with the image of these immense, glowing giants, stars so large they blur the boundary between object and environment, so vast that entire worlds could drift within them without ever reaching an edge. And yet, even they are temporary, part of a universe that is constantly changing, quietly reshaping itself, one transformation at a time. If you stay with that image of a massive star for just a moment longer, something subtle begins to change. What once felt expansive, stable, almost eternal, starts to reveal a quiet fragility, not in the sense of weakness, but in the sense of balance, because every star, no matter how large or luminous, exists in a kind of ongoing negotiation. On one side, gravity, always pulling inward, trying to gather everything into a tighter, denser form. On the other, the energy produced deep within the star pushing outward, resisting that collapse. For long stretches of time, these two tendencies remain in harmony, a steady exchange, a quiet agreement that allows the star to shine, not too violently, not too dimly, but with a kind of sustained presence. But this balance is not permanent. It depends on something finite, fuel. At the heart of a star, matter is continuously being transformed, not in a sudden burst, but in a steady process that releases light and heat. This is what gives the star its glow, its warmth, its ability to influence everything around it, and slowly, almost imperceptibly, that fuel begins to run out. At first, nothing dramatic happens. The star continues to shine. From a distance, it may appear unchanged. Its light still travels outward, reaching distant worlds and empty space alike. But deep inside, the conditions are shifting. The outward push begins to weaken. Gravity, patient and persistent, does not weaken. And so, gradually, the balance begins to tilt. The star starts to contract, not in a way that would be visible to the eye at first, but in a slow inward movement, layers pressing closer together, the core becoming denser, hotter, more intense. It's a quiet tightening, a gathering, and then, at a certain point, something changes. The inward collapse accelerates. What was once a gradual shift becomes a rapid transformation. The core compresses so quickly that the outer layers cannot keep up. Energy builds, pressure rises, and in a brief moment, short compared to the long life of the star, everything releases at once. This is what we call a supernova, but the word itself can sound dramatic, almost explosive in a cinematic way. In reality, it is something more inevitable, a release of accumulated imbalance, a final response to the loss of equilibrium. The outer layers of the star are pushed outward, expanding into space. Light spreads in all directions. Material that once formed part of the star is now scattered across the surrounding region, slowly drifting, cooling, becoming part of something larger. And what remains depends on the original star. If the star was smaller, it may leave behind a dense, compact object, something like a stellar ember still glowing faintly. But if the star was large enough, something stranger begins to form. The collapse does not stop. It continues inward, beyond the point where matter behaves in familiar ways. The core becomes so dense, so tightly compressed, that our usual descriptions begin to lose meaning, and from this process, a black hole can emerge, not as a hole in the way we imagine a gap or an empty space, but as a region where gravity has become so strong that it changes how space itself behaves. But we'll move into that more gently, in time. For now, it's enough to sit with the transformation itself, because what makes this process quietly profound is not just its scale, but its continuity. The material that once formed a star does not disappear. It changes form. It spreads outward, becoming part of clouds of gas and dust that drift through space. Over long periods, those clouds may gather again, forming new stars, new systems, perhaps even new planets. And somewhere within those future systems, the same elements may come together in ways that allow something else to emerge, something that can observe, reflect, and wonder. There's something deeply cyclical about that what feels like an ending is also a beginning, not in a dramatic or intentional sense, but as a natural continuation of how matter and energy move through the universe. Stars form, shine, and eventually let go. And in letting go, they create the conditions for what comes next. It's a quiet reminder that nothing in the universe remains fixed. Even the most massive stars, even the ones that can engulf entire planetary systems, are temporary. Their brilliance is not permanent. Their structure is not final. They are part of a larger flow, a slow, ongoing transformation that spans vast stretches of time. And yet, from a distance, all of this is invisible. A star may appear steady for millions or even billions of years. Its light unchanged, its presence constant. Only when we look deeper, when we begin to understand what is happening beneath the surface, do we realize how dynamic it truly is, how much is changing, or even when nothing seems to. And perhaps that reflects something broader about the universe, that much of what feels stable is only stable for a time, that balance, while real, is often temporary, and that change, when it comes, is not sudden or arbitrary, but the result of processes that have been unfolding quietly all along. As we continue forward, we'll begin to follow that transformation to its next stage, to the structures that form when gravity takes hold completely, when collapse does not stop, and when the familiar rules of space and time begin to blur. But for now, you can rest with this image, a star, once vast and luminous, slowly losing its balance, gathering inward, and then, in a brief and quiet moment, releasing everything it once held, not as an act of destruction, but as a transition, a turning point in a much larger story, one that continues to unfold far beyond any single star. As your awareness continues to drift outward, past stars that swell and fade, past the quiet endings that give way to new beginnings, something else begins to emerge, not suddenly, not dramatically, but as a quiet consequence of everything we've already seen. When a star grows large enough, and when its balance is finally lost, the collapse that follows does not always stop. It continues, inward, deeper, beyond the point where familiar structures can hold, and from that continued collapse, something forms that is difficult to picture, not because it is chaotic, but because it is so precise, so complete, that it changes the way space itself behaves. This is what we call a black hole, but the name can be misleading. It suggests an emptiness, a hole, something missing. In reality, it is not empty at all. It is a region where matter has been gathered so tightly, so completely, that its presence reshapes the space around it. And to understand it, you don't need equations or complex descriptions. You can begin with something much simpler. Imagine a gentle surface, like a calm, stretched fabric. If you place something small on it, the surface dips slightly. If you place something heavier, the dip becomes deeper. Now imagine placing something so dense, so concentrated, that the surface bends in a way that becomes impossible to climb back out of. Not because something is pulling you inactively, but because the shape of the surface itself no longer allows an easy path outward. This is not a perfect analogy, but it offers a feeling, a sense that gravity is not just a force, but a shaping of space. And in the case of a black hole, that shaping becomes extreme. There is a boundary surrounding this region, a kind of threshold, not a wall, not a surface you could touch, but a point beyond which returning is no longer possible. This boundary is often described as the event horizon, but you can think of it more gently, as a point of no return if something crosses that boundary, whether it is a particle, a beam of light, or even something much larger. It will not come back out. Not because it is trapped in a dramatic way, but because the paths that lead outward simply no longer exist. All directions lead inward, even light. And that is perhaps the most striking detail. Light, which travels faster than anything else we know, which can cross vast distances in what feels like no time at all, cannot escape once it passes this boundary. It doesn't slow down in the way we might imagine. It simply follows the shape of space, and that shape leads inward. From a distance, this creates a curious effect, because if light cannot leave, then the region appears dark, not because it is empty, but because nothing that happens within it can be seen from the outside. It becomes a kind of silhouette, a shadow, not cast by the absence of something, but by the presence of something so complete that it allows no light to return. Around this dark region, space itself begins to behave in unusual ways. Light passing nearby does not travel in straight lines. It curves, not sharply, not abruptly, but gently, following the contours of the space it moves through. This means that objects behind a black hole can appear distorted, stretched, even multiplied in strange ways as their light bends around the region. Time, too, begins to shift. Not in a way you would feel directly, but in how events unfold. From far away, something moving toward this boundary would appear to slow down, not because it is resisting, but because the flow of time itself changes in that region. Moments stretch, processes take longer. What might be a brief motion from one perspective becomes a slow, lingering approach from another, and yet, from the viewpoint of the object itself, nothing feels unusual at first. There is no sudden jolt, no dramatic signal, just a quiet continuation into a region where returning is no longer possible. There is something deeply strange about that such an extreme boundary does not announce itself, that it exists not as a barrier you can see or touch, but as a condition that quietly changes what paths are available. And perhaps this is where the feeling begins to deepen, because black holes are not rare. They're not isolated curiosities. They're a natural outcome of how stars evolve throughout the galaxy and beyond. There are many of these regions, each formed from the quiet ending of a massive star. They drift, they move, they exist as part of the larger structure of the universe, not separate from it. And most of the time, they're not something to fear in an immediate sense. They do not roam actively seeking out anything. They simply exist, shaping the space around them, influencing what passes nearby. And yet, understanding them changes something. It reveals that there are places in the universe where the rules we are familiar with begin to soften, where direction loses its meaning, where returning is no longer an option, not because of violence, but because of geometry, because of how space itself is arranged. And that realization is not sharp or sudden, it is quiet, a kind of gentle unease, the awareness that the universe contains regions where even light, the very thing that allows us to see, cannot carry information back to us, places that are not hidden by distance, but by their very nature. And as we continue, we'll move a little closer to the center of this idea, to the place where our understanding becomes less certain, where questions begin to gather without clear answers. But we will take that step slowly. For now, it's enough to rest with the boundary itself, a quiet edge where light cannot return and where the universe reveals a different side of its structure. As you remain with that quiet boundary, that edge where light cannot return, it's natural for the mind to begin asking a simple question. What lies beyond it? Not in a dramatic sense, not as something waiting or hidden, but simply as a continuation of curiosity. If something passes that boundary, where does it go? And what happens next? These are questions that scientists have asked for many years, and despite everything we've learned about the universe, despite our ability to observe distant galaxies, measure subtle shifts in light, and map the motion of stars, the answer here becomes less clear. Not because we haven't tried, but because the nature of this region makes it difficult to observe in the usual ways. When light cannot return, information cannot return. And without information, our understanding begins to rely on something quieter, inference, careful reasoning, built on what we know about how matter, energy, and space behave, extended gently into a region we cannot directly see. From that reasoning, a picture begins to form. At the centre of a black hole, there is thought to be a point, or perhaps a region, where everything that has fallen inward becomes compressed. Not in the way we experience compression in everyday life, not like pressing something into a smaller shape, but in a way that pushes matter beyond the limits of what we can meaningfully describe. This idea is often referred to as a singularity, but even that word can feel heavier than it needs to, because it suggests something precise, something defined. In truth, it is more like a placeholder, a way of saying, beyond this point, our current understanding does not extend. It is not that we know exactly what exists there. It is that when we try to apply our current models, the descriptions begin to break down. Concepts like size, density, even time and space themselves, become difficult to define in the usual way. And so, rather than forcing a clear image, it can be more helpful to approach this idea gently, to think of the centre of a black hole not as a specific object, but as a place where our familiar ways of describing reality simply fade, a place where questions remain open, and that, in itself, is not unusual. There are many areas of science where understanding reaches a boundary, where the tools we have are not yet sufficient to go further. But what makes this particular boundary feel different is how closely it is tied to something we can describe quite well. The outer regions of a black hole, the boundary, the bending of light, the slowing of time, these are areas where our understanding is strong, where predictions match observations. But just a little further inward, that clarity softens, and this creates an interesting contrast, a structure where the outside is well understood, but the centre remains uncertain, a kind of gradient, from clarity to mystery. And perhaps this is where the tone shifts slightly, not toward fear, but toward curiosity, because while it's natural to imagine the unknown as something unsettling, it can also be seen as something unfinished, a space for future understanding, a reminder that knowledge is not fixed, but always expanding. Still, there is something quietly profound about the idea that within the universe, there are regions where our current descriptions simply do not apply, where the language of physics, as we know it, reaches its limit, and beyond that limit, we do not yet have the words. If you try to imagine what happens to something that falls inward, you might picture it being pulled, stretched, compressed, and in a sense, that is part of the story. But as the process continues, those familiar descriptions become less useful because the conditions become so extreme that they no longer resemble anything we encounter elsewhere. It's not just that things are more intense, it's that the framework we use to describe them begins to lose its meaning, and so, rather than forcing an image, it can be more calming to accept that this is a place where imagination pauses, where understanding is still in progress, where the universe holds something, not hidden, but simply not yet fully described. There's a certain quiet honesty in that even with all we've learned, there are still places where we say, we don't know yet. And that statement is not a weakness. It is a reflection of how knowledge grows, step by step, boundary by boundary, always reaching a little further. As you sit with this idea, the feeling may not be one of fear, but of depth. The sense that the universe is layered, with regions of clarity and regions of mystery, all existing together, and that moving from one to the other is not abrupt, but gradual, like walking into a fog where the world doesn't disappear all at once, but slowly softens, until only the immediate surroundings remain visible. The centre of a black hole is something like that. Not a sharp edge, but a place where visibility fades, where the details become less defined and the questions become more open, and that openness can be held gently. There's no need to resolve it tonight, no need to fully understand it. It's enough to recognize that such places exist, that within the vast structure of the universe, there are regions where our knowledge reaches a quiet pause, and beyond that pause, there is still more to discover. As we continue, we'll step back slightly, not deeper inward, but outward again, to look at scale in a different way, to see how even these mysterious regions are part of something much larger, structures so vast that even black holes begin to feel small by comparison. But for now, you can rest with this thought, that at the heart of some of the most extreme objects in the universe, there is not a clear answer, but a question, and sometimes that is enough. If you gently step back now, away from that quiet center where understanding fades, something interesting begins to happen again. The sense of scale shifts. What once felt like the most extreme thing imaginable, a region where light cannot return, where space bends inward, where questions remain unanswered, begins to take on a different role. Not as the largest structure, but as part of something larger. Because black holes, as immense and mysterious as they are, do not exist in isolation. They are woven into a broader cosmic landscape, and within that landscape, there are objects so vast, so luminous, that even the most massive stars we've imagined begin to feel smaller, quieter, almost secondary. Some of these objects are powered by black holes themselves, but not in the way we might expect. Instead of hiding completely in darkness, they can become some of the brightest phenomena in the universe. This happens when matter, gas, dust, fragments of nearby material begins to drift toward a black hole, not all at once, and not directly inward, but gradually, forming a kind of slow, spiraling motion. As this material moves closer, it doesn't fall straight in. It begins to circle, faster and faster, forming what we might imagine as a thin, glowing disk around the black hole. Within that disk, friction builds. Not the kind you feel when rubbing your hands together, but a more subtle interaction where particles influence each other, transferring energy as they move. This energy has to go somewhere, and it is released as light. Not dim light, but intense, radiant emission that can outshine entire galaxies. And at the center of this process, there may be a black hole of extraordinary scale. One such example is TON 618. It's difficult to fully grasp what that means, so instead of numbers, we can approach it gently through comparison. Imagine placing multiple solar systems side by side, each with its own star, planets, and empty space between them. Now imagine something that stretches across that entire arrangement, not as separate systems, but as a single, continuous region. That is the kind of scale we're approaching, a structure so large that the familiar distances between planets and stars begin to lose their meaning. And yet, even here, the black hole itself is not what we see directly. What we observe is the light from the surrounding disk, the energy released as matter moves inward. From far away, this creates the appearance of something brilliantly luminous, a beacon in the darkness of space. But at its heart, there is still that same quiet region where light does not return. There is something almost paradoxical about that one of the brightest objects in the universe can be powered by something fundamentally dark, that the presence of a black hole can give rise to immense light, not by shining itself, but by shaping the motion of everything around it. And as you sit with this image, something else begins to emerge, a sense that scale, once again, is shifting. Because while this object is vast, while it stretches beyond what we can easily imagine, it is still not the largest structure in the universe. It is still part of something greater. It exists within a galaxy, a collection of stars, gas, dust, and dark matter, all moving together in a slow, complex dance. And that galaxy itself is not alone. It is one among many. As you step back further, where you begin to see that even these immense objects, these glowing centers powered by enormous black holes, are just small points within a much larger pattern. Clusters of galaxies, grouped together, filaments of matter, stretching across space, and between them, vast regions of emptiness. But we'll move into that more gently soon. For now, it's enough to rest with the idea. That scale in the universe does not stop where we expect it to. Each time something feels like the upper limit, there is another layer beyond it, a larger structure, a wider context, and within that expanding view, even the most extreme objects begin to feel relative. There's something quietly humbling about that what once seemed like the most powerful, most overwhelming presence becomes just one part of a larger whole, not diminished, but recontextualized, seen from a different distance, a different perspective. And perhaps that is one of the subtle lessons of exploring the universe. That understanding does not always lead to certainty. Sometimes it leads to expansion, to realizing that what we know fits within something even larger, something not yet fully explored. And that process continues. As we move forward, we'll begin to shift our attention again, not toward individual objects, but toward the environment they exist within, the space between stars, the structure of galaxies, the slow movement of everything through the cosmos, and, in that transition, the feeling will change once more, from intensity to something quieter, something more expansive, a sense not of overwhelming force, but of distance, of separation, of the vast spaces that lie between everything. But for now, you can rest with this image, a luminous region, powered by motion, surrounding a quiet center where light cannot return. An object so large it spans the scale of multiple solar systems, and yet, still just one part of something far greater. As you gently step back once more, away from luminous regions and quiet centers, something begins to unfold on a much larger scale. The focus softens, not because things become simpler, but because they become broader. Instead of looking at a single star or even a single black hole, you begin to see the space around them, the environment they belong to, the larger structure that holds them together. A galaxy. Our galaxy, the Milky Way, is not something we can easily see from the outside. We're inside it, moving along with it, much like being within a vast forest where the trees stretch in every direction. From within, it can feel open, scattered, difficult to grasp as a whole. But if you could step far enough away, if you could look back from a distance, you would see something more organized, a gentle spiral, arms of stars curving outward from a brighter center, like a slow whirlpool of light. Not spinning rapidly, not chaotic, but moving with a kind of steady, patient motion. And within this structure, there are hundreds of billions of stars, each one with its own story, its own path, its own surrounding space. Our sun is just one of them, one small light, located in one of the outer regions of this vast arrangement. And as you begin to imagine this, something important becomes clear. Nothing in a galaxy is truly still. Every star is moving, not randomly, but along paths shaped by gravity, slowly orbiting the center of the galaxy, taking immense stretches of time to complete a single journey. If you were to follow the path of our sun, you would find that it moves through the galaxy in a wide, sweeping orbit, a journey so long that what feels like a complete cycle to us, entire civilizations rising and falling, is only a tiny fraction of that larger motion. Everything is drifting. Stars pass near each other over long periods of time, then move apart again. Clouds of gas gather and disperse. Regions of space become denser, then thinner. It is not fast, but it is constant. And within this slow movement, there is a structure holding it all together. Not something you can see directly, not something that glows or reflects light, but something that influences everything around it. This is what we often refer to as dark matter. The name might sound mysterious, but you can think of it more gently, as an unseen presence, a kind of quiet scaffolding that gives shape to the galaxy. Without it, the stars would not move in the way they do. The outer regions would drift away more easily. The structure would be less stable, less cohesive, but with it, the galaxy holds together, not tightly, not rigidly, but just enough to maintain its form. And so, even though we cannot see this unseen component directly, we can sense its influence in the way everything moves. It's like watching leaves drift along a current you cannot see, but know must be there. And as you sit with this image, a galaxy full of motion, something else begins to emerge, a feeling of scale, not just in size, but in time. Because everything we've described so far, the movement of stars, the orbit of the sun, the slow shaping of the galaxy, unfolds over timescales that are far beyond everyday experience. Changes happen, but slowly, so slowly that from a human perspective, the galaxy appears almost frozen. But it is not. It is evolving, quietly, and this brings a different kind of awareness. Not the intensity of massive stars or the mystery of black holes, but something more subtle, a sense of being part of a system that is always in motion, even when everything feels still. Right now, as you listen, the Earth is turning. It is moving around the sun, and together with the sun, it is travelling through the galaxy, following a path that has been unfolding for millions of years and will continue long after. There is no pause, no moment where everything stops, only continuous movement, layered upon movement, and yet, from where you are, it feels calm, steady, almost motionless. This contrast between what is felt and what is happening is one of the quiet themes that continues to appear as we explore deeper. That stillness can exist within motion, that stability can exist within change, and that what seems fixed is often part of something far more dynamic. As your awareness expands further, beyond individual stars and their paths, you begin to see that galaxies themselves are not isolated either. They move, they drift toward one another. Sometimes they pass close, sometimes they merge, their structures blending over long periods of time, not as collisions in the usual sense, but as slow, graceful interactions. Stars rarely crash into each other directly. Instead, their paths shift, their orbits change, the overall structure evolves, and in that evolution, new patterns emerge. But we won't rush too far ahead. For now, it's enough to sit with this image, a galaxy, vast and gently curved, filled with countless stars, each moving along its own path, yet all part of a shared motion, a system that feels still from within, but reveals its movement when seen from afar. And within that system, a small planet, carrying you, moving quietly through it all. As we continue, we'll move into a different kind of environment, not one defined by stars and light, but by absence, by the spaces between, where motion continues but becomes harder to perceive, where the distances grow so large that even light takes long journeys between one place and another. But for now, you can rest here, within the slow, steady motion of a galaxy, turning quietly in the vastness of space. As you rest within the slow motion of the galaxy, surrounded by countless stars, each glowing softly in its place, it's natural to imagine that every world must belong to something. A planet, circling a star, a system, held together by light and gravity, a rhythm of day and night, warmth and shadow, sunrise and sunset. It feels intuitive, almost necessary. But as we continue to look more closely, that assumption begins to loosen, because not all worlds belong to a star. Some drift, alone. These are often called rogue planets, but even that name carries a tone that feels more dramatic than the reality. They are not escaping anything, not searching for anything. They are simply moving, quietly, through the vast spaces between stars. These worlds likely began the same way many others did, forming within young star systems, gathering material, slowly shaping themselves over time. But at some point, perhaps during the early chaotic stages of their system's formation, they were pushed away. A close gravitational interaction, a shift in orbital paths, a gentle but decisive change, and suddenly they were no longer bound to their star. They were released, not violently, but permanently. And once that connection is gone, something else begins. A long, quiet journey through interstellar space. Without a star nearby, there is no steady source of light, no sunrise, no sunset, just a constant, unchanging darkness. If you were somehow able to stand on the surface of such a world, there would be no sky filled with warm light, no shifting colours at the horizon, only a vast dark expanse, perhaps scattered faintly with distant stars far too weak to illuminate the ground beneath you. The concept of a day would lose its meaning. Time would still pass, but not in a way marked by light, only in subtle changes, quiet processes unfolding slowly. And yet, these worlds are not necessarily frozen, lifeless spheres. Some of them may still hold warmth, not from a nearby star, but from within. Deep beneath their surfaces, there may be heat left over from their formation, energy slowly released from their interiors, warming layers below the surface. In some cases, this internal warmth could be enough to maintain pockets of liquid, hidden beneath thick layers of ice, not visible, not exposed, but present. A quiet reminder that even in darkness, processes can continue. There is something deeply still about that idea. A world with no sunlight, no visible source of energy, and yet beneath its surface, something persists. Not in abundance, not in a way we would easily recognize, but quietly, sustained. These rogue planets may wander like this for billions of years, passing through regions of space where stars are distant and sparse, occasionally moving closer to a star system, only to continue past it, unaffected. They do not settle, they do not orbit, they simply drift, and there may be many of them, perhaps as numerous as the stars themselves, scattered throughout the galaxy, silent, unseen, moving along paths shaped only by gravity and time. It's a different kind of existence, not defined by connection, but by separation. And as you sit with that image, something subtle begins to take shape, a sense of loneliness, but not in a human, emotional way. More like a spatial loneliness, a condition of being far from everything else, of moving through regions where encounters are rare, where distances stretch so far that even light takes long journeys between one point and another. But this is not a hostile environment in the way we might imagine. There are no storms, no sudden events, no dramatic forces acting on these worlds, just stillness, a quiet, continuous motion through darkness. And perhaps that is what makes them so intriguing, that in a universe often defined by extremes, heat, pressure, energy, there are also places defined by absence, by the lack of those things, worlds where nothing dramatic happens, where change is slow, where time stretches gently, without interruption. And yet, these worlds are still part of the galaxy, still part of the same structure that contains stars, planets, and everything we've explored so far. They are not separate, just less connected. And that distinction begins to shift the way we think about the universe. It suggests that not everything follows the patterns we expect, that there are paths and outcomes that exist outside the familiar rhythms, not as exceptions, but as natural variations. And as we continue outward, that sense of separation will grow, the distances will expand, the connections between objects will become more tenuous, and the spaces between them will begin to dominate. But for now, you can rest with this image, a quiet world, drifting through darkness, carrying with it the remnants of its formation, moving gently through a galaxy full of light, yet belonging to none of it. No sunrise, no sunset, only the slow passage of time, and the distant glow of stars that never rise and never set. As you remain with the image of a solitary world, drifting quietly through darkness, something else begins to come into view. Not an object, not a star, but the space itself. The vast regions that stretch between everything we've explored so far. Between stars, between planets, between those wandering worlds that belong to nothing at all. It's easy to imagine space as being filled with things, stars scattered like points of light, galaxies spiraling, planets orbiting. But what begins to reveal itself slowly is that most of the universe is not made of these objects. It is made of the distance between them, a kind of quiet backdrop, so large that everything else seems to float within it. If you were to take all the stars in a galaxy and spread them out across the space they occupy, you might find that the distances between them are far greater than the stars themselves, and between those stars, there is very little, not absolutely nothing, but close enough that the difference becomes subtle. A few particles here and there, traces of gas, drifting, occasional grains of dust, moving slowly through the dark, But compared to what we're used to, it is almost empty. You might think of it as a kind of cosmic desert, not made of sand, but of absence. A place where resources are not just scarce, but nearly non-existent. There is no steady warmth, no nearby source of light that can provide energy in a consistent way. Even the glow of distant stars, while visible, is too faint to have any meaningful effect on the environment. And this is where something important begins to emerge. Because while we often focus on the dramatic aspects of the universe, the massive stars, the intense heat, the powerful forces, there's another challenge that is quieter, but just as significant. Distance. Not just distance as something to measure, but as something to experience. Imagine travelling through this space, not quickly, but at a pace that still feels incredibly fast by everyday standards. Even then, the journey between one star and the next would take an immense amount of time. Years, turning into decades, into centuries, into spans so long that they begin to lose their usual meaning. And during that journey, there would be very little change, no shifting landscapes, no passing landmarks, just a gradual movement through a region where everything looks almost the same. Dark, still, occasionally punctuated by distant points of light that never seem to grow closer, at least not in any noticeable way. This is what we might gently call an energy desert, not because there is no energy at all, but because there is so little available, and it is so spread out that sustaining anything complex becomes extremely difficult. Life, as we know it, depends on a steady flow of energy, on gradients, differences, changes that can be used to drive processes. But in this vast, quiet space, those gradients are minimal. Everything is thin. Everything is distant. And that makes the idea of travelling across it, or existing within it, far more challenging than it might first appear. It's not that something would immediately go wrong. There is no sudden danger, no immediate threat. But over time, the lack of energy, the lack of interaction, becomes its own kind of barrier, a quiet limitation. And this is where the scale of the universe begins to feel different again. Not overwhelming in the sense of intensity, but in the sense of separation. Because even though stars are numerous, they're also incredibly far apart, and between them lies this vast, nearly empty expanse. As you sit with this idea, it begins to shift the way you think about movement, about travel, about connection. Because reaching another star is not just a matter of direction, it is a matter of endurance, of sustaining motion across distances where there is almost nothing to support you along the way. And even if you could move continuously, even if you could maintain that motion for long periods, the journey itself would still unfold slowly, not because of any resistance, but because of the sheer scale involved. There is something quietly humbling about that the universe is not just filled with extraordinary objects, but also with extraordinary distances. That separation itself is one of its defining features, and that most of the universe exists not in the form of stars or planets, but in the form of space. Space that is not empty in an absolute sense, but is so close to empty that for many purposes it might as well be. And yet, even within this emptiness, there is still motion, still subtle change, particles drifting, fields extending, time passing. It is not a void in the sense of nothingness. It is a quiet environment where very little happens, but where everything still exists, and perhaps that is where the tone shifts again, from the intensity of stars and black holes to something more subdued. A recognition that the universe is not only defined by what is present, but by what is absent, by the vast stretches where nothing dramatic occurs, where silence, in a physical sense, dominates. And as we continue, this idea will deepen, because the spaces between stars are only one layer. Beyond them, there are even larger regions, spaces between galaxies, regions where the distances grow even greater, and the sense of isolation becomes more pronounced. But for now, you can rest with this image, a quiet expanse stretching between points of light, where motion continues slowly, and where the absence of energy becomes its own kind of presence. Not threatening, not dramatic, just vast. As you remain with that quiet image of interstellar space, that wide, dim expanse where stars are separated by distances almost too large to hold in mind, something small begins to move within it. Not a star, not a planet, but something far more delicate, something made not by natural processes, but by intention, a human-made object, slowly drifting into that vastness. These are the Voyager probes. Launched from Earth many decades ago, they began as tools of exploration, instruments designed to study the outer planets of our solar system, to gather data, to send back images, to extend our understanding just a little further than before. At the time, they were not meant to leave forever. They were part of a mission with a clear purpose, a beginning, a middle, and what was expected to be an end. And yet, something unexpected happened. After completing their initial journeys, after passing by the giant planets and sending back their quiet streams of information, they kept going. There was nothing to stop them. No boundary marking the edge of the solar system in the way we might imagine a border or a wall. Just a gradual transition from the region influenced strongly by the sun into the broader space between stars. And so they continued, not quickly, not dramatically, but steadily, moving farther and farther away from Earth, from the sun, from everything that once defined their origin. Even now, they are still travelling, not with purpose in the way we understand it, not guided toward a destination, but simply following the motion they were given at the moment of their launch. A quiet continuation. And as they move outward, something else travels with them. Each Voyager carries a small object, something that was never meant for scientific measurement, but for something more reflective. A record, often called the Golden Record. It is a collection of sounds and images from Earth, simple things in many ways, the sound of wind, of water, of voices speaking in different languages, music captured from different cultures, images of landscapes, of people, of life as it exists on this small planet, and alongside these, instructions, not written in words, but encoded in a way that could, in principle, be understood by any sufficiently curious observer. A kind of quiet introduction, not announcing, not demanding, but simply offering a glimpse of where the probe came from. There is something deeply gentle about that idea, that as these small machines drift into the vastness, they carry with them a fragment of what it means to be human, not in full detail, not in complexity, but in essence. And as they move farther, away, something else becomes clear. They are leaving us, not in a dramatic sense, not as something lost, but as something that continues beyond our reach. The signals they send back grow fainter over time. The distance increases, the connection stretches thinner, and eventually there will come a point when even that faint communication will no longer be possible, not because something has gone wrong, but because the distance has simply become too great. At that point, they will continue alone, still moving, still carrying their records, but no longer in contact with the place that created them. And if you pause with that thought, it begins to take on a different kind of meaning. Because these probes are not just machines, they are, in a quiet way, extensions of us. They represent our curiosity, our desire to reach outward, to understand what lies beyond our immediate surroundings, and yet, even they are limited. They move at incredible speeds by everyday standards, faster than anything we experience in our daily lives. But even so, their journey through interstellar space is slow, so slow that reaching even the nearest stars would take spans of time far longer than a human lifetime. They're not explorers in the sense of arriving somewhere new. They're travellers, moving through distance itself. And as time continues, something even more subtle begins to emerge. These probes may outlast us, not in the immediate sense, not in a way that suggests anything sudden or dramatic, but simply because of how long they can continue drifting. Long after their power sources fade, long after their instruments fall silent, they will still exist. Small, quiet objects moving through the galaxy, carrying within them a record of a world that may have changed or even disappeared long after they were launched. There is something both humbling and strangely comforting about that a small piece of what we are could continue even as everything else evolves, not preserved perfectly, not active or aware, but present, a trace, a memory. And as you sit with this image of a small, silent object drifting through a vast and quiet space, it begins to connect with what we explored earlier, the idea of distance, the idea of an energy desert, the sense that moving between stars is not just difficult, but deeply time-consuming. Because even with our most advanced creations, we've only just begun to step into that space. We have not crossed it. We have not reached the next star. We have only entered the edge of that journey. And perhaps that is where the tone settles, not in limitation as something negative, but as something real, a recognition of scale, of what is possible, and what remains beyond reach, at least for now. The Voyager probes do not represent failure. They represent the beginning of something, a first step taken carefully into a vast and quiet expanse. And as we continue, we'll begin to explore why that journey is so difficult, not in technical terms, not with equations or precise measurements, but in a way that feels more intuitive, a way that reveals how distance, energy, and time combine to create a kind of quiet barrier, not imposed, but inherent in the structure of the universe itself. But for now, you can rest with this image, a small, golden record carrying the sounds of Earth, drifting slowly through the darkness, moving farther away with each passing moment, yet still part of the same story. As you remain with the image of those small machines drifting outward, carrying their quiet record of Earth into the darkness, a gentle question begins to form. If they can go, why can't we follow? Not as a challenge, not as something to overcome immediately, but as a simple curiosity. What is it exactly that makes this journey so difficult? Because on the surface, it might seem straightforward. If something can move forward, if it can continue travelling through space, then perhaps, given enough time and effort, we could do the same. But as we look a little closer, the difficulty reveals itself, not in a single obstacle, but in a combination of three quiet realities: distance, energy, and time. Let's begin with distance. The space between stars is not just large, it is vast in a way that does not translate easily into everyday experience. If you imagine travelling from one city to another, or even across an ocean, the journey, while long, still feels bounded. There is a sense of scale that the mind can hold. But between stars, that sense begins to dissolve. Even the nearest star beyond our sun lies so far away that light, the fastest thing we know, takes years to arrive from it. Not moments, not minutes, years. And light does not move slowly. It travels at a speed so great that it could circle the Earth many times in a single second, and still, it needs years to cross that distance. Now imagine travelling that same path, not as a beam of light, but as something physical, a spacecraft, even at incredible speeds. Far beyond anything we have built so far, the journey would take far longer than a human lifetime. Not because something is resisting the motion, not because space is difficult to move through, but simply because the distance itself is so great. And that leads gently into the second reality, energy. To move something across such distances, or especially at high speeds, requires a tremendous amount of energy, not just at the beginning, but continuously. You would need to accelerate, to maintain that motion, and perhaps, eventually, to slow down again. Each of these steps requires energy, and in the quiet emptiness of interstellar space, there is very little available to draw from. No atmosphere to push against, no nearby fuel sources, no steady external input. Everything you carry must be brought with you, and that creates a kind of balance. The more energy you carry, yes, the more mass you add, and the more mass you add, the more energy you need to move it. It becomes a loop, a quiet limitation, not imposed by any barrier, but emerging naturally from how motion and energy relate to one another. And even if we imagine future technologies, more efficient systems, new ways of generating or storing energy, the scale of the challenge remains not impossible, but deeply demanding. And then there is time. Even if the journey could be sustained, even if the energy requirements could be met, the duration itself becomes a defining factor. A voyage between stars would not unfold over days or months. It would stretch across years, decades, perhaps longer, and during that time, everything else continues. Life on Earth changes, generations pass, the world evolves, and the traveller remains in motion. There is something quietly profound about that. That to leave our solar system in a meaningful way is not just a technical challenge, it is a commitment to time itself, a willingness to move beyond the rhythms we're used to, beyond lifetimes, beyond familiar scales of change. And perhaps that is where the realization settles in, not as a limitation in the negative sense, but as a reflection of where we are. We're at the beginning. We've taken our first steps outward. We have sent small machines beyond the immediate reach of our sun. We have begun to understand the distances, the requirements, the challenges, but we have not yet crossed that space. And that is not a failure. It is simply where we are in the larger story, because the universe is not arranged around our pace. It does not adjust its scale to match our expectations. It simply exists, with distances that are immense, with energy distributed in subtle ways, with time scales that extend far beyond our immediate experience. And within that structure, we are learning, step by step, understanding more, not by rushing outward, but by observing carefully, thinking deeply, and expanding our perspective. As you sit with this idea, the tone shifts again, from the outward motion of Voyager to a quieter recognition that the journey between stars is not blocked. It is open, but it is vast, and that vastness shapes what is possible and how we approach it. And even if one day we find new ways to travel, new methods to cross these distances more efficiently, the scale of the universe will remain unchanged, still stretching outward, still offering paths that are long, quiet, and filled with time. As we continue, we'll look at another aspect of this journey, not just the difficulty of moving through space, but the challenge of existing within it, the subtle conditions that affect anything travelling through that vast quiet environment. But for now, you can rest with this understanding that the distance between stars is not just something to measure, it is something that defines the experience of the journey itself, a quiet, expansive separation that invites patience, reflection, and a deeper sense of scale. As you sit with the idea of distance, of long, quiet journeys across a nearly empty expanse, another layer begins to reveal itself, not something large, not something obvious, but something subtle, because the challenge of travelling through space is not only about how far you must go, or how long it might take, it is also about what surrounds you along the way, and in many cases, what surrounds you is not dramatic. It is not something you can see clearly, not something you can hear, but it is there, quietly present. One of these subtle elements is radiation, not the kind we might associate with bright light or heat, but a more delicate, invisible form of energy. Tiny particles, moving through space, carrying energy with them. They do not form storms. They do not gather into visible clouds. They simply pass through. In many parts of space, these particles are constantly moving. Some come from stars, released over time as part of their natural activity. Others arrive from more distant sources, travelling across the galaxy, carrying traces of events that happened far away. And when these particles encounter something, they interact, not always in ways we can feel directly, but in ways that matter over time. For living systems, this interaction becomes important, because life, as we know it, depends on structures that are delicate, cells, molecules, arrangements of matter that hold together in very specific ways. And when these tiny, energetic particles pass through, they can gently disrupt those arrangements, not instantly, not dramatically, but gradually. A small change here, a subtle alteration there, and over time, those changes can accumulate. It's not a sudden threat, it's a quiet influence, one that becomes more significant the longer you remain exposed. And in the vast openness of space, there's very little to shield you from it. On Earth, we are protected in ways we rarely notice. The atmosphere above us absorbs much of this incoming energy. The magnetic field surrounding our planet gently deflects many of these particles, guiding them away from the surface. We live beneath layers of protection that soften the environment in ways that feel natural. But beyond that protective envelope, those layers fall away, and what remains is a more direct interaction with the space around you, a quieter, less filtered experience of the universe. Radiation is one part of this. Another is something even smaller. Microscopic particles, tiny fragments of matter drifting through space, not large enough to see, not frequent enough to form anything like a storm, but present and moving, even at moderate speeds. These particles carry energy, and when they encounter something solid, the interaction, while small, is still real. For a spacecraft, over long periods of time, these interactions can slowly affect surfaces. Tiny impacts, subtle changes, nothing dramatic, but cumulative. And for something more delicate, something biological, the environment becomes even more complex. Because life depends not only on structure, but on stability, on maintaining conditions within a certain range, temperature, pressure, chemical balance. All of these factors are carefully regulated within living organisms, but space does not provide that regulation. It does not adjust. It does not stabilize. It simply exists, and so, to survive within it, you must bring your own stability with you, your own environment, your own protection, And even then, that protection must be maintained continuously. There is something quietly revealing about that. That space is not actively hostile in the way we might imagine danger. It does not seek to harm. It does not change in response to your presence. But it is also not accommodating. It does not provide what is needed for life. It does not adapt. And so, the challenge becomes one of balance, of maintaining a small, stable pocket within a vast environment that does not support it, a kind of quiet persistence. And as you reflect on this, the tone shifts once more, from distance to limitation to fragility. Because even though we have developed the ability to move beyond our planet, to send machines into the wider universe, the conditions of that universe remain unchanged. They are not shaped for us. They are not softened for comfort. They simply are. And within that reality, our presence becomes something delicate, not insignificant, but dependent on maintaining conditions that allow life to continue. And perhaps that is where a deeper understanding begins to settle in. That exploration is not just about reaching new places, it is about sustaining ourselves within environments that are fundamentally different from the one we evolved in. And that requires care, attention, and a recognition of limits, not as barriers, but as features of the environment itself. As we continue, we will move into a different kind of space, not just the regions between stars, but something larger still. Spaces where not only energy, but matter itself becomes sparse, where the universe begins to feel less like a collection of objects and more like a vast, quiet absence. But for now, you can rest with this idea that beyond the challenge of distance, there are quieter influences at work, invisible, subtle, constant, shaping the experience of anything that moves through the open space between the stars. As you gently move beyond the idea of fragile journeys, beyond the subtle dangers that accompany motion through space, something even quieter begins to take shape, a different kind of space, not the space between stars, but something larger, something that exists between entire galaxies. Up until now, the universe may have felt like a place filled with things, stars scattered across the darkness, galaxies spiraling, glowing faintly in the distance, occasional regions of motion, of energy, of transformation. But as your awareness expands further, a different pattern begins to emerge. Most of the universe is not made of these things. It is made of what lies between them, vast regions where matter becomes incredibly sparse, where galaxies are few and far between, where even the faint glow of distant stars becomes rare. These regions are often called cosmic voids, but the word void can sound more dramatic than necessary. It suggests emptiness in an absolute sense. In reality, when these regions are not completely empty, there are still particles, still faint traces of matter, still the quiet presence of space itself. But compared to the rest of the universe, they are astonishingly empty. To begin to sense their scale, it can help to think in gentle comparisons. Imagine a single galaxy, a vast collection of stars, gas and dust, all moving together. Now imagine another galaxy, far away. Between them, there is space, but now expand that idea. Imagine not just the distance between two galaxies, but regions where entire clusters of galaxies are separated by immense expanses, spaces so large that if you were to travel through them, you might go for an incredibly long time without encountering anything substantial. One such region is known as Bhuta's Void. It is sometimes described as a great nothing, not because it contains absolutely nothing, but because, relative to its size, it contains very little. Galaxies that would normally be scattered throughout space are largely absent here, the distances between them become even greater. The density of matter drops, and what remains is a vast, quiet expanse. To imagine this, it can help to soften the idea, not as a place of darkness filled with threat, but as a place where very little happens. No dramatic events, no frequent interactions, no steady flow of energy, just space, extended, still. And in that stillness, something interesting arises, a kind of quiet paradox. Because even though these regions are vast, even though they stretch across unimaginable distances, they can evoke a feeling that is almost the opposite of what you might expect. Not openness, but a kind of gentle confinement. Not because there are walls, but because there is so little variation, so little change, so little to orient yourself by. Imagine drifting through such a region. No nearby stars growing brighter as you approach. No shifting patterns of light. Only distant points, scattered so sparsely that they barely change over time. Movement continues, but without landmarks, without reference points, it becomes difficult to perceive. Time stretches, space stretches, and everything begins to feel uniform. There is something deeply quiet about that, not in the sense of silence as the absence of sound, but as the absence of activity, a region where the universe is not expressing itself through dramatic events, but through stillness. And as you sit with that idea, another realization begins to form. These voids are not rare, they are not exceptions, they are a major part of the universe's structure. Galaxies tend to gather along vast thread-like patterns, forming what is sometimes described as a cosmic web. Clusters and filaments of matter interconnected across immense distances, and between those filaments, these voids expand, not as gaps in the structure, but as part of the structure itself, as important as the galaxies, as the stars, as everything we have explored so far. In fact, if you were to consider the total volume of the universe, these quiet regions make up the majority, which means that most of the universe is not filled with light or matter. It is filled with space, space that is nearly empty, space where very little occurs. And this shifts the perspective once more, because earlier, the universe may have felt intense, filled with extreme environments, massive stars, powerful forces, complex interactions. But here, the dominant feature is not intensity, it is absence, not danger, but emptiness. And that emptiness is not hostile. It does not act, it does not change rapidly, it simply exists. And in that existence, it becomes one of the defining features of reality. There is something quietly humbling about that the most common environment in the universe is one where almost nothing happens, where motion continues, but without interaction, where time passes, but without noticeable change. And yet, even within that stillness, the universe continues to evolve, very slowly, very gently, because these voids are not static, they expand, gradually, not in a way that would be noticeable from moment to moment, but over immense spans of time, they grow. The regions between galaxies become larger, the distances increase, and the quiet emptiness becomes even more prominent. As we continue, we will explore what that expansion means, not just for the structure of the universe, but for what can be seen and what can be known. But for now, you can rest with this image of vast expanse, stretching across unimaginable distances, where the absence of matter becomes the defining feature, not a place of threat, not a place of action, but a place of stillness, where the universe, in its quietest form, simply continues to be. As you rest within that vast stillness, those quiet regions where almost nothing happens, another subtle movement begins to reveal itself, not within the voids, not within the galaxies, but in the space that connects everything. A motion so gentle, so gradual, that it cannot be felt directly, and yet it is always there. The universe is expanding. This does not mean that galaxies are moving through space in the usual sense, like objects drifting across a fixed background. Instead, the space between them is stretching, very slowly, almost imperceptibly. If you imagine two distant points, not moving on their own, but the space between them gradually becoming larger, that begins to capture the feeling. They are not travelling away in the way we might walk away from each other. They are being carried apart and by the expansion of the space itself. This is a quiet kind of motion. There is no central point where everything began to move outward from. No single direction that defines the expansion. Everywhere, the same pattern appears. From any point in the universe, distant galaxies appear to be moving away. Not because they are choosing to, but because the space between everything is slowly increasing. And this increase is not fast on the scale of human experience. It is almost unnoticeable. You would not feel it. You would not see objects around you drifting apart. Everything local, planets, stars, even galaxies bound together by gravity, remains intact. But over vast distances and over long periods of time, the effect becomes clear. Galaxies that are far away become even farther. Light that begins its journey toward us must travel through space that is gradually stretching along the way. And as it travels, something interesting happens. Its wavelength becomes longer, not in a way you would notice directly, but in a way that changes the character of the light. It shifts, gently, toward lower energy, toward a softer, quieter form. This is one of the ways we know the universe is expanding, not through direct observation of motion, but through the subtle transformation of the light that reaches us. And as you sit with this idea, the feeling is not one of speed or urgency. It is something else, a slow drifting apart, a gentle separation that unfolds over immense spans of time, and this leads to a quiet consequence. As the universe continues to expand, more and more regions become separated by distances so large that light can no longer cross between them, not because it stops moving, not because it is blocked, but because the space itself is stretching faster than the light can bridge. And when that happens, those regions fade from view. Not suddenly, not dramatically, but gradually. They become dimmer, more distant, until eventually they are no longer visible at all. From our perspective, the universe would appear smaller, not because it has changed in size, but because less of it is observable. Fewer galaxies, fewer points of light, a quieter sky. And if you extend this idea far enough into the future, something remarkable begins to take shape. Observers in that distant time, if they existed, might look out into the cosmos and see only their own galaxy. Everything else would have drifted beyond the range where light could reach them. The vast structure we now observe, the clusters, the filaments, the distant galaxies, would no longer be visible. Not because they're gone, but because they're too far away to be seen. There is something deeply subtle about that the universe does not simply expand, it gently limits what can be known. Over time, that observation itself becomes constrained by distance. That knowledge, in a physical sense, can fade, not through loss, but through separation. And yet, this process is not abrupt. It is not something that would be noticed from one moment to the next. It unfolds slowly, so slowly that it would feel like a steady, unchanging reality, a sky that simply contains fewer distant objects, and that would be normal from that perspective. There is something quietly profound in that what we are able to see today, the richness of the observable universe, is not guaranteed to remain. It is a moment, a phase, a window in time, where distances have not yet stretched too far, where light from distant galaxies still has time to reach us. And as that window shifts, so too does our view, not in a dramatic way, but in a gentle narrowing. And perhaps this brings a different kind of awareness, not of fear, but of context, that we exist at a time when the universe is still visible in its broader form, when its structure can still be observed, when its history can still be traced through the light that reaches us, and that this ability is not permanent. It is part of a larger unfolding, a quiet evolution of what can be seen and what remains beyond reach. As you sit with this idea, the tone becomes softer, not heavier, not more intense, but more reflective, because the expansion of the universe is not something that threatens. It does not act against us. It simply continues, steadily, uninterrupted, and within that continuation, everything, drifts, galaxies, clusters, light itself, all carried along by the gentle stretching of space. And as we move into the final part of this journey, we will return, not outward, but inward again, back to a small planet, within a single galaxy, within a universe that is vast, dynamic, and quietly indifferent. But for now, you can rest with this image, a universe slowly opening, stretching, creating more space between everything, not through force, but through time, a quiet separation unfolding endlessly across the cosmos. As you sit with that image of a universe slowly drifting apart, where distances grow, where light fades, where even entire galaxies may one day slip beyond visibility, something begins to shift once more, not outward, but inward, back through the vastness, back through the quiet regions where almost nothing happens, through the sparse stretches between stars, through the slow movement of galaxies, through the immense structures that seem to stretch without end, back to something smaller, something quieter, something familiar, a small planet, orbiting an average star in the outer regions of a single galaxy, Earth. It does not stand out in the way we might once have imagined. It is not at the centre of anything. It is not surrounded by special markers or boundaries that distinguish it from the rest of the universe. From a distance, it would be almost impossible to notice, a tiny point, lost among countless others. And yet, when you look more closely, something becomes clear. This place is different, not in size, not in position, but in balance. Because everything we have explored so far, the immense heat of stars, the crushing density of collapsed objects, the vast emptiness of interstellar and intergalactic space, exists according to the same underlying rules, the same patterns, the same quiet unfolding of matter and energy. And within those rules, most environments lean toward extremes, too hot, too cold, too sparse, too intense. But here, on this small planet, those extremes are softened, not eliminated, but balanced. The distance from the sun is just right to allow temperatures where water can exist in a flowing state. The atmosphere is thick enough to protect, but not so dense that it becomes overwhelming. The magnetic field gently deflects many of the invisible particles that pass through space, shielding the surface from constant exposure. The rotation of the planet creates cycles of light and darkness, allowing periods of activity and periods of rest. None of these features are extraordinary on their own, but together they create something rare, a stable environment, not perfectly stable, not permanent, but sufficient. Sufficient for life to emerge, to grow, to adapt, and eventually to become aware of itself. There is something quietly remarkable about that within a universe filled mostly with conditions that do not support life, there are small pockets where life can exist, not because the universe was designed for it, but because, within the range of possibilities, certain combinations allow it. And Earth is one of those combinations. As you reflect on this, the earlier sense of scale returns, but in a different way, not as something overwhelming, but as something contextual. The vastness of the universe does not diminish the significance of this place. It highlights it, because in a universe where most environments are not suited for life, the presence of a place that is becomes meaningful, not in a grand cosmic sense, but in a quiet, immediate way. The air you breathe, the ground beneath you, the subtle warmth of the sun. These are not universal conditions, they are local, specific, and in many ways, uncommon. And yet, within this uncommon environment, something has emerged that can look outward, that can observe distant stars, study galaxies, imagine black holes, and reflect on the nature of the universe itself. That can ask questions, not just about what exists, but about what it means. There is something deeply gentle about that realization, that the ability to feel, to think, to wonder, exists within a small region of balance, surrounded by vast regions where such experience is not possible. And perhaps that is where the tone settles, not in fear, not in awe alone, but in a kind of quiet appreciation, because understanding the universe does not necessarily make it more frightening. It makes it more complete. It reveals both the extremes and the rare moments of balance within those extremes. It shows us that the universe is not shaped around our comfort, but it also shows us that comfort can exist within it, in small, fleeting ways, and that those moments are worth noticing. As you sit here, listening, breathing, existing within this small, stable environment, everything we have explored continues. Stars are forming and fading, galaxies are drifting, space is expanding, void regions are growing, all of it unfolding quietly, beyond immediate perception, and yet, here, in this moment, there is stillness, there is warmth, there is awareness. And that contrast between the vast and the immediate is part of what makes this experience meaningful, not because it resolves the scale of the universe, but because it exists within it, and perhaps that is enough. You do not need to hold the entire universe in your mind. You do not need to resolve every question or understand every detail. It is enough to recognize where you are, a small point within a vast structure where conditions align just enough to allow you to be here, now. And as the universe continues its quiet unfolding, that moment remains, not permanent, not fixed, but present. And so, as this journey gently comes to a close, you can let that awareness settle. The universe is vast. It is in many ways indifferent. It does not adjust itself for life or for comfort. And yet, here you are, within a small, rare balance, able to observe it, to reflect on it, and perhaps to feel a quiet sense of connection to it. And that is something quietly extraordinary.